Hello students, this demonstration video is about how you can complete your assignment 6. Assignment 6, I'm just going to run this program here, is adding a new option to the airport application, and that is offering the passenger sitting on the plane the ability to display a list of movies that he or she can play while on the aircraft, and also to search for a movie by year. So here, as you can see, this is the movie selector menu. And when the user of the airport application, as you can remember, when they enter E, they go into emergency decisions. When they enter R, they go into flight status reporting. And so when they enter M, they go into this movie selector menu, and which has these three options. Now, if I say D, then as you can see, here are a bunch of movies that are available for viewing. And if I would like, for example, this list could have been really very long, but I'm just going to say I would like to search for a movie, let's say released in the year 1990, and then enter your choice. It's search and then 1990, and then the movie comes up as available. If I enter S for search my movie, and then I enter maybe any number here, which is not a valid number, or it's a year in which the movie is not part of the database, then it says sorry, movie not found. Now, when I go back to do display here, I'd just like to point out one thing, that as you can see, these movies, they are not ordered in any particular order. I have 2000, 1975, 1950. So this seems to be an unordered list. That's the first thing that I'd like to point out. This movie database program is very key because through this example, you will be learning how to do user-defined data types called structs. You will also be building on this to sort the database using selection sort. You will be searching through the database using a search technique called binary search. These are all very powerful and very standard techniques which are part of your curriculum. So you will be doing all of this by updating or doing the back-end work for this particular menu option, which is the the movie selector program. Another thing that you will be doing as we move forward for the rest of the semester is that we will introduce the concept of classes. That will also be done by upgrading this particular program. And then finally, we will be introducing pointers, which are a reference to addresses, again using this particular program. So this template is going to undergo several modifications during this semester. So therefore, it will be worth your while to really examine and complete this. This is a simpler template that has fewer options than the other ones, and it has got fewer functions. So having said that, this is unordered, and as you see in your later assignments, you will learn how to sort so that they appear in a sorted order of ascending order, and then also searching them using a much more efficient search than just doing a linear traversal of the array. So let me quit out of this application and go to the template so that I can show you how you can work with your template. This is the template that you've been given. Now, the data file that you see here has got 6 entries. These entries have been separated by commas. The reason why this has been developed as a CSV file or a comma-separated file is because you want to give the name of a movie which has got many words, and these words are separated by spaces. So we would like to use another separator. We would not like to use space as a separator. We would like to use a comma as a separator. We could have used anything, but because it's tradition to use commas to separate the fields. So this is the field, which is the name of the movie, then followed by the year of release, followed by the director of the movie, followed by the genre, and then the actors who are playing their roles inside the movie. So this is how the file has been structured. And I would request you to watch the video on structs, which is a lecture video on how to create user-defined types using structs. And that will explain to you that each one of these entries actually forms a record of movie information. And we would like to store this as a structured record. We would not like to store this as a string array because there are many fields inside it. And one of these fields we would like to store as an integer. And struct allows us to create records like this, and where each individual field can be a different type. For example, I may have a type which is of double here instead of the romance, and then also have character, or have Boolean types and so on. So these are 6 records, and these are going to be stored in an array, very like the flight status reporter array, but it's not going to be an array of string, but it's going to be an array of structs, which are called movie. This is the type is going to be called movieData, and we will create an array called my movies, and each of the elements inside this array is going to be a record of type movieData. So that's all I'm going to say about this, and now walk through the main program. The main program, usually you are used to having the main program with just one function call. In this one, what I've chosen to do is to split this into a few functions. Here's where I create the file variable, and here's where I create the database. Now, as you can see, the type here is not integer or string, but the type here is actually movieData. And I will show you where I got this type from. So in order to do that, we need to go into our header file. And here is where I've used the struct feature of C++ and said, I would like to create a structure or a user-defined type called movieData, which will contain a string, an integer, and these strings. Now I can use the type movieData to create an array so that each element of the array contains a record of type movieData. So that's the idea. Now let me just go back and show you all the functions. There are not too many. And we will also go through the execution chart to see the sequence in which the functions are called. And so the first thing I do is I create my database. I set my file name and try to open the file. In your previous examples, you have seen that I have checked to see if the file is open or not. And if the file is not open, you just exit saying a file open error. And we don't see that here. And in a minute, we will see why this is not done here and why file open validation is still done, but it's done in a different way, in a new way, and in a very effective way. So after opening the file, and note that if the file doesn't open, the program is going to terminate. And then here we populate the database by passing the file variable and passing the database, and we get in turn the size of the database. If you look into the movie header file, you will see that I've created a constant number of movies. So the size of the database is 20, which means the maximum number of movies that I can store is 20. But as you know, the file only has 6 entries, and it could have, for example, had 7. We don't know. So in order to take care of that varying number, up to a maximum of 20, we have the populate database go through the file and return the final count of entries in that file. And we save that. And now we go into the movie selector menu and pass the completely populated database and the number of entries in that database so that we can scan it easily. So let's go into the movie database. Here, the movie selector menu has these three options. If the user enters S, it searches the movie. If it enters D, display the movie. Now here, as you can see in your template, when I say do not change, this means this function is complete. You do not need to make any changes. And some of these functions are very familiar to you, like input choice and display menu and all of that. Now, if the user enters D, then you will need to display the movie list. So here, actually, why don't I let you write this? Complete this function. So here I'm going to put the star star, and so that you know this, you have to complete the function here. So complete the function by traversing this database and calling the display selected movie function. So the display selected movie function has been written for you. It's right here. The reason why it's written for you is because I have already set certain column widths and I won't want you to struggle with that. But the display movie calls this to display each individual display each individual record. All right. So the search option, when the user enters S, then we go into search movie, and then the user is queried, can you please enter the year of the movie in the YYY 4 places format, reads in the year, and then fills in this function, which traverses the array in a linear way from the beginning to the as many records there are, and tries to match the year of the year field with the year that the user has entered. And if there's a match, displays that movie, otherwise says, sorry, movie not found. Now, here are some of the methods that have already been written for you. I just like to quickly go through them. The open file, here is the new thing, the exception handling. Try-catch statements are an exception handling feature or a structure in C++, where whatever you would like to, whatever function or whatever operation you'd like to do is enclosed in the try. So here I'm going to try to open the data file. And this returns to me, if I check data.fail, I will know if I was able to open or not. Now here, if the file, if it was not possible to open the file and there was a failure, then what I'm going to do is I'm going to throw an exception or throw a message to the operating system. That message is caught in the catch part of the try-catch statement, and it will simply display the error and exit the program. So the reason why we do this and not use an if-else statement is because we can also, for example, not have an if here and just try datafile.open, and if there is an issue with that, then automatically one goes to the catch part of the try-catch statement, and the exception handling is done there. So this is just an introduction to the try-catch statement, and as you can see, what happens here is that we don't just we just completely exit the program if the file doesn't open, and that makes a lot of sense. Now, when we do populate database, then here's where the actual accessing the record syntax is occurring. So if I'm just going to say, if we have a record of type movieData and I call it M, then M dot director gives me access to the director field of this record that I've created called M. I can also initialize M with information here. I've chosen not to do that, but I can just create declare a variable or a record M of type movieData and say m.director is equal to, I don't know, Stephen S. or something like that. So when I use the dot notation, I'm actually accessing the fields of this record. And that's exactly what you see here. My movies count.title accesses, when count is equal to 0, it accesses the first array element and the field called title of that array element, right? So this is, if you look at this, you will see how to access. There's one last thing about structs that I wanted to mention to you. Let me see if I have it here. And that is, I don't see that here. It is possible to have a constructor, to create a constructor that initializes the values of these fields. And we will go over that. I think I have gone over that in my other video on structs, so I'd encourage you to go into that video. I wouldn't want to take up time over how to do the assignment specifications by going into more details of the constructor. But the constructor is a very important part of our learning, because when we move on to classes and objects, then for sure constructors are a core part of initializing objects, and how the user who has created an object can actually pass information on how to initialize the object, and in this case how to initialize that particular record. So but that's in the other video. So here we are, and once you complete these functions here, which have been, so the functions that you need to complete are the search movie and the display movie list. Let me see if there's any other. So basically you just need to complete these two functions, and you would have completed your assignment.